and I have the pleasure of walking through the most requested feature on our wasmCloud roadmap during our community planning session for earlier this year, wasmCloud Application Secret Support. Specifically, wasmCloud applications needed to be able to fetch and use secrets at runtime that are encrypted in transit and at rest. And as we proposed the design of secrets, it was critical that we approached adding secrets as an extendable layer and not tightly couple wasmCloud to any particular solution. It was also important to design this in a components native way with a standard interface so that it can be used in any language that supports WebAssembly components. We knew that we would provide an API as a collection of functions and types that developers could import into their code and write business logic in terms of secrets. Of course, this would also need to work just as globally distributed as wasmCloud does. So what is our solution? We designed the wasmCloud-Secrets WebAssembly interface, the pluggable secrets API over NATs, and we started implementing secrets backends or reference implementations. At the same time, we pushed updates to our application specification, WADM, and command line tools to support managing secrets in wasmCloud apps. On the right, you can see an example application. This is how it actually works today in a wasmCloud app that uses a policy to instruct wasmCloud how it can pull a secret at runtime, and then how the secret is specified in Vault down at the level of a component. So I want to show a couple of diagrams and talk through how this actually works in the wasmCloud ecosystem. So at runtime, wasmCloud is responsible for orchestrating WebAssembly components, and capability providers are also called native plugins. Secrets is actually a built-in host plugin that's configured as soon as wasmCloud starts and immediately is ready to support multiple secrets backends based on what applications declare in their manifest. Secrets backends are responsible for encrypting and storing the secret, which we know current secret solutions like cloud provider specific key stores or Hashicorp Vault are very good at. And wasmCloud is responsible for making sure that all secrets are encrypted in transit as they're fetched from the backend. Now we use NATS X keys for this, which are elliptic curve key pairs that provide strong cryptography and are actually very inexpensive to generate on the fly at runtime. So supporting this NATS API, which is how this secret solution is extendable and pluggable for wasmCloud and how we don't tightly couple to a particular solution, is using the NATS API. And supporting this is very simple. You supply a subject to wasmCloud when the host starts, and then your backend pluggable layer just needs to support two endpoints. The first one is just a request for the public key that the server is going to use to encrypt secrets in transit. And this is just returning the actual key that the backend is going to use. And the second and important one is an endpoint called GET, which is used to send the context of an entire secret request. So what secret needs to be fetched, what component is fetching it, what host is fetching it, what application the component belongs to. And then the backend can make a decision based on that or based on an external policy to return the secret or an error response. Now, this is, of course, going to be encrypted in transit. And every single time that this GET function is invoked, we generate a unique request X key, which prevents replay attacks, even if the NATS network itself for wasmCloud was compromised. Now, it's very important to know here that all secret fetching in wasmCloud is facilitated by the host itself. No components or capability providers actually fetch secrets on their own. They're just handed secret values. So this actually works a little bit differently for providers and components. So let's go through both scenarios. So you have an application that specifies a capability provider and it requires a secret. And WADM tells wasmCloud to start the capability provider as a part of deploying your application. So wasmCloud sees the specification that you've laid out for the secret, and it will send a request to the secrets backend that you have configured with the context of the provider and the application that's requesting it. The backend then will analyze that request and then allow the secret to be sent back encrypted over NATs. And then the host will actually start the provider along with two opposite pairs, two opposite pieces of a key pair. The provider receives the host public key and its own private key to use for secret decryption. And the host stores the host private key and the provider's public key for encryption later. So this ensures that this individual capability provider and only this instance of the provider can decrypt secrets sent by the host. If the provider or host is restarted, those keys are completely discarded and generated new if it starts again. So I included a little code sample here at the bottom, and this is almost exactly the line of code that we have in our host to do this encryption. But using the private key from the host, you can then seal or encrypt a secret value and specifically target that for a recipient, which is the provider's public key. So this is a very nice asymmetric encryption algorithm. Now, for components, this is a little bit different, but most of the entire process for fetching secrets is exactly the same. So when the component starts, if there's a dependency on a secret or the component specifies a secret, wasmCloud will request the secret from the backend. And then, since components are running alongside the host and there is no need to transmit that secret over the wire, we actually just cache that in memory with the secrecy crate, which ensures that the secret is zeroed out from memory as soon as the component stops. And then the component itself is able to access these secrets at runtime with the wasmCloud-Secrets interface. And the wasmCloud-Secrets interface, the two functions get and reveal, are actually built into the host. This is a built-in plugin. This is a key piece of innovation of the secret solution, not just making sure that we have encryption and decryption handled correctly, is the secrets WIT interface. This was meticulously designed. We collaborated with several folks in our community and champions within WASI land on the final design of this interface. And the end result is something that's really simple to use, but has a very key piece, a very key WebAssembly innovation that makes it special. The secret itself is initially fetched with the get function as a resource, which is actually an opaque pointer to the actual secret value. So when the component calls get, we don't actually load that secret into the component's memory. You can pass that secret around with other WIT interfaces that are designed with this secret type. So you can pass a secret from component to component, from component to provider, without ever revealing that value in memory. And then finally, secrets are actually entirely encrypted the entire way in transit and at rest, all the way up until a component or a provider reveals it. Now, this implication here around the usability is nice, but the real huge benefit is for platform teams, especially at enterprises where secrets need to be part of applications that aren't just like API keys or a token or a password, but they're sensitive data that should only be revealed under very strict circumstances. Customer data, PII, HIPAA data, payment information, all of that can now be sent all the way through a chain of applications without ever being revealed so that you can process that without seeing the secret itself, without ever actually loading the secret into memory. It's very impressive. I'm very proud of this part. Now, this was, again, we designed this with with other members of the WASI community, and the hope is to contribute this upstream as a WASI secrets interface as a phase one proposal as soon as we can. And all in all, you can see my excitement boiling over. I am incredibly proud of the secrets implementation and what our maintainers and community contributors were able to put together for this implementation for wasmCloud. And I'm very excited to see all the use cases and these implementations come to life. If you are interested in using secrets in a wasmCloud app, please check out our secrets documentation. The link is up at the top, but if you just go to wasmcloud.com and search for secrets, then there is great information about how to import the WIT, how to add secrets to your custom providers, and how to connect to your own secrets backend. So that is all that I have for the deep dive into secrets. Anybody watching, if you're on YouTube or in the webinar itself, please feel free to put in questions in the Q&A and I can get to them as I come off here.